I've said it before. We are here to talk about zero downtime, Oracle Grid infrastructure patching and read-only home. Next to me, I have the expert, which is Sandeep Sampath. He's our Oracle technical consultant at BCS here, or Blue Crystal Solutions. He has 10 years plus of experience in Oracle database administration. He's an expert in RAC, Oracle database installation, migrations, upgrades, disaster recovery and performance tuning, and has many skills in other areas, including RDBMS. I'm going to have to give my pronunciation, SQL Server, Postgres, MySQL, and MariaDB, and that's just to name a few. So the webinar that you're in today, it is running for 30 minutes. We expect about 20 minutes of that to be presentations and then 10 minutes of questions. We do welcome questions in the chat panel. We will have stocks for questions as well. So it's a very flexible structure. You will be prompted, but if you have a burning question, yeah, drop it in the chat. If you don't know about Blue Crystal Solutions, you will now, because we are experts in cloud applications, database, and IT infrastructure, and we have been since 2004. We essentially empower your organization with cutting-edge tech to maximize security, efficiency, productivity, and growth within your organizations. We obviously harness our technology partner ecosystem, and those partners are AWS, Oracle, Microsoft, and we work collaboratively with you, your team, and your wider organization to deliver best-of-breed IT solutions. So about you, if you're here, you're a techie wanting to expand your Oracle know-how or to understand how this particular technology that Sandeep's going to walk us through can support your organization. So that is it from me. I will hand over to the expert, Sandeep. Sandeep, it's all yours.
Thanks, Lauren. Good afternoon, everyone, for joining. Thanks for joining. So let me share my screen. Yeah. So welcome to this presentation on zero runtime Oracle Grid Infrastructure Patching and read-only Oracle Homes. We are going to discuss these topics in depth. The topic, and we'll provide you with strategies, insights, and best practices, to enhance your Oracle database management. So why are we looking at these two topics, and what are the main challenges that we have in traditional patching methods? For example, if you have a rack setup, currently running, at your organization. So as you know, if you have to patch your grid infrastructure, you need to restart your databases, because the database will get restarted when you patch. Even though you're doing a rolling patch, the database instances on the node will be restarted. And if you don't have transparent application continuity enabled, or if your application is not, can't tolerate those rolling downtimes, your application will receive an error, or the transactions that are running in your databases will receive an error, or they will fail, right? So that's one of them. And then if you're using OPatch Auto to patch both your database homes and your grid infrastructure, the length the OPatch Auto session runs, can be very long. So I've seen, wherein the OPatch Auto session takes about 98 minutes to complete in some of our customers' environments. So that's a long time. And even after that, so you need to again shut down your cluster to apply your OJVM patch, because the OPatch Auto will not apply the OJVM patch along with it. So, and then, there might be databases, that can't be patched at the same time. So we have different applications running on the clusters, and then, they can't be patched at the same time. It means that, you need to patch your grid infrastructure separately and then your database homes separately. So it means that we are introducing two service disruptions. And the other important bit is business continuity planning, so which we call it as disaster recovery solutions, where you have a standby database, but you have not tested your application against your standby databases, right? So we have customers wherein they have standby databases, but they can't fail over because they don't know whether their application will work when they're on the standby. So these are all the challenges that we have, and the other main challenge, challenge is, most of the organizations are now moving towards, they're tending towards, patching it every quarter. It means whenever a new patch is released. So earlier, they would have been doing, quarterly patching, or, they would apply patches once a year because they have to improve their security posture. So, they want to patch very frequently. It means that there is substantial effort and time involved. The DBAs, who are working, organizations might be spending a lot more time than what they are currently doing. So let's see how these two topics will address, these core challenges. So with that, so let's look at the first topic of the afternoon. So that's zero downtime Oracle grid infrastructure patching. As I've explained, in traditional patching of your grid infrastructure, even though you're doing in a rolling fashion, what happens is the instances on the node will be restarted. So when that happens, if there are any in-flight transactions, so those will fail, and then your application might receive an error, right? So with zero downtime Oracle grid infrastructure patching, so it's performed out of place. And then what happens during here is the major difference between the traditional patching and zero downtime Oracle grid infrastructure patching is the 19C database instances which are running on the cluster can remain online throughout the patching process. It means they never restart. And if there are any connections that are there in the database, they'll not be disrupted. So that's one of the main differences. And with traditional patching, if when the instances are down, it means you're running with a reduced capacity because you have only one instance available, and that might have an impact on performance as well. So whereas in zero downtime Oracle grid infrastructure patching, you don't run into that risk because you have all of your database instances available throughout your patching. So that's just an introduction. So let's look at what are the requirements. So there are some requirements and some limitations as well. So this is a new feature that was introduced with 19.16. So to take advantage of this feature, so you need to upgrade your grid infrastructure to 19.16. So if you're on later versions of your grid infrastructure, you can't implement this feature. And the databases that are managed by your GI must be 19C, right? So for example, if you have a 11G or a 12C database running, then they will restart during this time. But if all of your databases are 19C, then you can go ahead and implement this feature without any issues. So the other important requirement is, the presence of these drivers, which is ACFS, which is ASM clustered file system, your ASM filter drivers. So if you have any of these drivers installed and enabled, because there is a need to reload the driver, you can't implement this feature. So you have to check, whether you are using ASM filter drivers or you are using ACFS by running these commands. So if these two drivers are enabled and are being used, then you can't implement this feature because to update the drivers, you anyways have to restart your cluster or restart your servers. So you might have situations wherein the ACFS driver is installed but is not being used. If that is the case, then you can unload the driver and then implement this feature. And zero downtime Oracle grid infrastructure patching is only supported on rack configurations with 2 or more nodes. If you have rack 1 node or any other configuration, so then you can't implement this feature. So let's look at how to implement. The steps are pretty standard. So you create a directory on all of the nodes in your cluster, change the permissions. If you're using grid user, change the permissions to grid, and unzip your grid software. So update your patch to the latest version, which the patch requires. That will be available in the patch README. So once you have unzipped the software on the first node of your cluster, you can invoke grid setup.sh in silent mode with a couple of options, which is switch grid home and apply RU. So what it does is it will apply the patch first because you've updated the O patch. So it should apply the patch. If you don't update your O patch, it would just fail. So once you have updated your patch and run this, so it will apply the patch. And once you apply the patch, it will copy the software, the patch software onto all of the nodes in your cluster, and it will prompt you to run root.sh script. So this is where you have to run the root.sh script with transparent and no driver update. So this would, tell the installer to perform out of place patching without, taking down your 19c database instances on the node being patched. So the script that you run, the grid setup.sh, will only ask you to run root.sh. But if you run root.sh, as is, then it will be a rolling downtime. It means all of the instances on the node will be restarted. So you have to run your root.sh with transparent no driver update. So this will not update any of the drivers that we discussed previously. And the patching will be done transparently to the application, allowing all the 19c database instances to be available throughout the patching process. So some of you might be wondering, so how come the database instances can be online when my cluster is getting restarted? So the answer is here. So your 19c database instances that are running on the node that is being patched will be redirected to the ASM instance running on the remote node, so which is on the other node, right? So that's how they are able to remain online. So some of the other observations during this process is, so your listener will restart and your scan listeners will be relocated to the other node. Your CRS services will be stopped from your old grid home and will be restarted on the new patched home. Right. So any connections that are already in the database, they won't be impacted because the instance is not restarted. But any new incoming connections will be rerouted to the other node because the listener and the scan listeners will be failed over to the other node. So any questions at this point? Okay. So the other important aspect of this is the rollback. Now we have done patching. So how do I roll back? So the first scenario is, okay, what happens if the patching fails on one of the nodes, right? So how do I roll back? The first thing that you'll have to do in that situation is to run the root crs.sh with the pre-patch option. So that will unlock your grid home. And then you'll have to run the post-patch script on the node where patching failed. So using the rollback option and using the same options with no driver update and transparent. So, but the only difference is your destination CRS home will be your old grid home. So once you have executed these two commands successfully, your grid infrastructure will be running from your old grid home. The second situation is you have performed the patching on all of the nodes in the cluster and you're running on the latest patch set, but then you have encountered an issue and then you want to roll back. So in that situation, the first thing that you'll have to do is you'll have to unlock your old grid home first, and then you'll have to run the switch grid home from your old grid home to switch back all of the services to your old grid home. So as we have seen, what are some of the benefits of zero downtime patching? So continuous availability is one of them, because your database instances are not restarted during patching, so they are continuously available, and there is minimal disruption to your application. Even applications who do not tolerate rolling downtime can now tolerate those downtimes. So it means there's less disruptions. And you can apply the patches, without causing any issues. So it allows you to keep your grid infrastructure up to date with the latest patch sets, and you don't have to perform this patching, out of business hours. You can do this patching, now during business hours because it doesn't impact anyone.
All right.
Yeah.
So I think I'll throw to the group. If you've got any questions, please do pop them in the chat now before we move on to the second part of this session. Or good if you don't have questions. While in case people are madly typing over there or they're not, I actually have a question for you, Sandeep.
Yeah.
So what do you consider to be the biggest challenges users may face when implementing this?
Mainly the drivers. See, the Oracle documentation is pretty contradicting. So what they say is, they say you can still implement this feature with, where you have all of those drivers installed. But what they say is then, it's not supported in, like 24 hours, or, like it's not supported for an extended period of time, which is, they say you'll have to update your drivers, within 24 hours. So, but that configuration is still supported, because we have seen, we have had customers where what we have done is we have updated one of the nodes in the cluster to the latest patch set, and we have done the patching of the other node on the next day. So it means that you can have different versions or different patch sets across your cluster. The other challenge is, where you have different versions of database running on the same cluster. So as I said, if you have a mix of databases like 12c and 11g, then you can't implement this feature, because those databases, if they are critical, they'll anyways restart and then cause disruptions. So those are the two main, you can say, challenges that one can have while implementing this feature.
Great, thank you. All right, so we've got one question. I'll read it out. This one is from Emmanuel. We have a GI environment in place, but we don't have a rack. Can this still be performed on such an environment? We have a physical standby in place.
So no. So this feature is only supported for a rack with 2 or more nodes. So if you have a single node rack or a rack 1 node, you can't implement this feature. Yes, if you have rack with standbys, you can still use these features on your standby environments as well.
All right.
So does that answer your question, Emmanuel?
He says thank you.
Yeah.